Good afternoon, Town. Can you hear me? Town, can you hear me?
Good evening, sir.
Very good evening. Hi, Nitesh. How are you?
Yes, I'm fine, sir.
Okay, great. Where is Sankar?
So he's joining, sir, I think.
Okay, sure.
Yeah, he's joining now.
Yeah, Sankar has also joined. Good evening.
Good evening, sir.
Very good evening. How are you?
Fine, sir. So what happened, sir?
Yes,
There
now we
was
are good,
some
sir.
network problem, so that's why I couldn't join on time.
Pankaj, is your hand okay?
I don't know that it's okay. Decreased a bit. Hey, I win the bet.
No, sir,
Okay,
mine
so
is now.
okay, start. Is screen visible to all of you?
No, sir.
Yes, sir.
I hope it is now visible, right? Is it now visible?
Yes, sir.
Okay.
That's the paper.
So, what we have studied in the previous, where we have reached? I hope you remember.
Mendeleev's atomic
Periodic table.
periodic table. Yeah, period.
Exactly. Mendeleev's periodic table. Have we completed that? We have studied perhaps
Yes.
the achievements and the limitation, right?
Yes, sir.
Sir, we were doing limitation.
Yeah, we were doing limitations.
What were the achievements? First, tell me what were the achievements of Mendeleev's periodic table?
I didn't think we studied that, sir.
Exactly. They are not
We didn't
studied.
study achievements, sir, but we were
Exactly.
doing
Let's first discuss
limitations.
the various achievements. That is the important contributions of this periodic table. Then we will move towards the limitations. So let me write here. We will first see the various achievements. So is it visible? Achievements of Mendeleev's periodic table. So I will write Mendeleev's periodic table as MPT, right? So the first achievement, the first very important contribution of this periodic table, that was the systematic study of elements, right? Am I audible?
Yes, sir.
Can you hear me?
Yes, sir.
Okay. So I will write it here. That is the systematic study of systematic study of systematic study of elements. So as you know that in the Mendeleev's periodic table, all the elements, they have been actually arranged in increasing order of their atomic mass, isn't it? So that means elements with similar properties, they have been kept within a same group. So that means if you know the property of one of the element in a particular group, you can tell the properties of other elements. So it becomes very easy and useful, right, in studying and remembering the properties of large number of elements. So I will write it here that in the systematic study of elements, what Mendeleev did, he kept elements in increasing order of atomic weight. And now what happened because of this? Because of this, all those elements which have similar property, they are present within a same group. I will write it here that, and the elements having similar property, and elements having similar property, and the elements having similar property, similar properties are kept within a SAM group, right?
Yes, sir.
Within a SAM group. Okay. Now, so because of this periodic table, it is now easy to remember. And if we know the property of one of the element, for example, if I will just talk of, let's say, group second. In group second E, we are having beryllium, there is magnesium, isn't it? I hope you
Yes,
remember a
sir.
little bit. Yeah, then it is
Till
the
20 we know.
exactly beryllium, magnesium, calcium. Okay, then it was the strontium, and then it was the barium. It is the just group second E. I hope you remember this group second E. Now, see, if you just know that beryllium forms oxide having formula BeO, then you can easily tell that magnesium will also form same type of oxide, that is MgO. Calcium will also form the same type of oxide, that is CaO. Strontium will also follow the same, it will also form the same oxide, that is strontium oxide and barium oxide, isn't it? Similarly,
Yes.
if you know that beryllium forms hydride having formula BeH2, then you can easily tell the formula of the magnesium hydride. You can easily tell the formula of calcium hydride, isn't it?
Yes, sir.
So this is the systematic study of elements. Where is Sankalp? Sankalp, can
I
you hear me? Is he there?
no, I don't think he's there, sir.
Where they have been?
Only I am there, I think.
Where
They're
is
there in the
Thorn?
meeting. They're there in the meeting. Everyone's there in the meeting, sir.
Okay, they are in the meeting.
Yes, sir. But they're muted.
Okay. So I hope that they are listening.
So I can listen.
Yes,
I'm
sir.
listening to you.
Yes,
You
sir.
can listen, but audible.
Okay. Why you are not responding? Sankalp, Thorn,
Sir,
Nitish?
I didn't know you were calling me. So I thought you were only calling something.
I didn't realize I was.
Okay. So this is the first
Hello, sir.
achievement. Yeah. Where was you?
Sir, sorry, sir. I was actually trying to connect my headset, sir. It was not working.
Okay. Is it now fine?
Yes, sir. Sir,
Okay.
what were you doing, sir?
I'm just sharing the screen. Today topic we have started, that is the achievement of Mendeleev's periodic table. The first achievement which I told, that was the systematic study of elements. I told that Mendeleev he kept elements in increasing order of atomic weight, and the elements having similar properties they are kept within a same group. For example, if we just talk of group second A, that is beryllium, magnesium, calcium, strontium, barium, they will form this type of oxide, that is BeO. So that means if you know the formula of one of the oxide, you can tell the formula of other oxides also. It's now easy. It is now systematic. There is a systematic way, there is systematic study in this Mendeleev's periodic table. For example, if you know that beryllium forms hydride of the formula BeH2, so magnesium will also form MgH2, calcium will also form CaH2, strontium will also form SrH2, and barium it will also form same type of hydride, that is BaH2. So got it now?
Yes, sir.
So shall I move to the next page?
Yes, sir.
Okay, now let's see the next achievement. That is a very important achievement, that is the correction of doubtful atomic weights. Correction of doubtful atomic weights. Correction of doubtful atomic weights. See, before Mendeleev's periodic table, it was told that beryllium, its mass was told as 13 13.5. Its mass was told as 13.5. But if it was like that, then where it should be placed? For example, it is first lithium, then we are having beryllium. Actually, what Mendeleev have placed here, lithium, beryllium, then it is the boron, carbon, nitrogen. We know that
It'll be
lithium,
like
it's
lithium, boron, carbon, nitrogen, beryllium.
So
Yeah, right.
boron, its atomic number is 5, so mass is 11. Carbon, it is 6, mass is 12. Nitrogen, it is 7, mass is 14. So first it was told that beryllium is having mass 13.5. If it was having mass 13.5, then where it should be placed? It should be placed here between carbon
After
and nitrogen.
carbon, before nitrogen.
Exactly. Exactly. After carbon, before nitrogen. But no space was left by Mendeleev. Mendeleev actually corrected its weight. He told that its weight is not 13.5, but its weight is 9. So he just placed this beryllium between lithium and boron because its property they just resemble with magnesium, calcium, as I already told you, strontium, isn't it?
Yes,
So
sir.
this was the correction of atomic weight, which was done by Mendeleev. So this is
Only
also another.
beryllium.
Not only beryllium, he also corrected the atomic mass of indium, gold, platinum, various
Oh,
elements. But
okay, sir.
this one is very famous, beryllium. You can
Sir,
also
but
remember.
in our
Okay.
textbook they gave beryllium as 9, sir.
It is 9.
Yeah, exactly. Beryllium mass is
Oh, okay,
9.
okay. Okay, I thought he put 9 and the correct one is 13.5.
No, 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 no. He just took it as 9, and this 9 is correct one. This is 13.5, which was actually told earlier before Mendeleev.
Okay, okay. Yes,
Yeah.
yes.
So along with beryllium, he also corrected the weight of gold. Gold symbol is Au, right? I hope you remember. Gold symbol is Au, and similarly, he also corrected the mass of indium. Indium is In. Indium. Indium. And similarly, he also corrected the mass of platinum, Pt. Pt stands for platinum. Platinum. So this was the second achievement of Mendeleev's periodic table. Then it is the third one that's very important. That is the prediction of new elements. I hope you remember that in the Mendeleev's periodic table, there were some spaces, empty spaces or vacant spaces, right?
Yes, sir.
Prediction of new elements. So can you tell me where it was the space? Which element
Sir,
Mendeleev has actually predicted?
The
sir,
noble gases.
in group 8, row 3, and in group 7, row 7, 7, and in group 4, row 4,
I will tell you. I will tell you.
uh,
The
And
periodic
group
table.
3A, third one. In group 4A, third one again. That's
no,
what
not
Exactly.
third one, not third one. It's the
third one
fourth one.
only.
The fourth
It
one.
is the third A. Third A, as I have already told.
Exactly.
After it is the boron, then it is the aluminum. After aluminum, there was gap, as I have
Sir,
Yeah,
already
it
it's
told
is.
you.
third one.
Sir, it is 3A fourth row and 4A fourth
Exactly,
row.
it is 3A.
Third
It
row,
is
da.
3A.
No, it's
For
fourth
that
row.
group. For that group. Not excluding the group one thing.
What?
I know hydrogen is in the first row, but still.
Bruh.
See now here. First, we are having hydrogen in the first period. Then this boron, it belongs to the second period. Aluminum belongs to the third period. Gallium, it will belong to the fourth period. That's correct. So,
Yes.
but you have to remember the group. In which group it was actually there? It was the third A, right? Third A group. In third A, we are having after aluminum, it was the empty space left here. This is that of the, it
And
was
then group
actually known as.
4A, fourth.
Can you tell me what was the name given by Mendeleev for this gallium? What was the name given for this gallium by Mendeleev?
Gallium.
Mendeleev, no, he told it as Ica aluminum. So can you tell me what do you mean by Ica aluminum? Ica means which will actually come after aluminum. Are you getting?
Oh,
Yes,
that's a
sir.
Ica,
nice name.
yeah, it is simply Ica aluminum.
Did he name
That
it,
means
sir?
Sir, then he can name everything as 1 after hydrogen, 2 after hydrogen, 3 after hydrogen.
exactly as Ica. Exactly. This
So
Ica
what is
means
it?
after. EKA, it is just EKA. That means after. It means after. So that means after aluminum, the next element which was then discovered. So Ica aluminum, it was your gallium. So you have to remember that Ica aluminum, it was your gallium which got discovered later on. And he also predicted the properties of this. For example, what oxide is formed by this boron? That is B2O3, isn't it?
B2O3.
Exactly.
Yes.
Aluminum it forms Al2O3. Similarly, gallium will also form Ga2O3, isn't it?
Yes, sir.
Exactly. So can you tell me the next element which was not discovered at the time of Mendeleev, and then he just kept the empty space for that element? Shall we move
Uh,
to the next page?
That's the fourth A.
That was exactly in the fourth A. So what was the fourth A?
Fourth
So group 4A.
column. Carbon, silicon, and then blank.
Exactly. After silicon, it was the empty space here, and that is your. It was known as Ica silicon, right?
phosphorus,
EK.
right?
Yes, sir.
What is Ica silicon? When
After
it was
Phosphorus.
After silicon.
it is the germanium.
So
Ge.
what?
G is
Germany.
G is
Oh, it's like in the group wise. Okay, sir. Like
yeah, it is group wise. Exactly. Carbon, silicon, then it
I
is the
thought it was
germanium,
period
then
wise.
it is the tin, yeah, then it is the lead PB. So that means
Sir,
he
SN
just
is tin, right, sir?
Can you go to
SN
the
is
previous page once?
What
sure,
are you
sure.
doing there?
Just write it down.
What is that? EKA
sir.
minus AL gives GA. What is
After
Hey,
gallium.
Ika aluminum, yeah.
It is not minus, that means it is Ica aluminum. It is just dash
After
here.
aluminium, which is gallium.
Hey, I didn't know the dash there. That's it.
Yeah,
Dash
it is
what?
Ica aluminum. Ica aluminum. It was the element which was then discovered later on. It is the actually gallium. But
So we can go to
Mendeleev
the
told
next page.
yeah, but Mendeleev told this as Ica aluminum, but this is actually now the germanium and gallium. Similarly, Ica silicon. Ica silicon. It is our gallium which was discovered later on. So he also predicted the properties of this germanium. Just for example, he told that carbon forms CO2 oxide, silicon forms SiO2. So germanium will also form GeO2. Or
Yes,
you
sir.
can also write their hydrides. For example, carbon forms CH4, methane. Silicon, it forms SiH4. So germanium will also form GeH4. So these properties, they were predicted by the Mendeleev, and these property they were true. When these elements they got discovered, their property actually matches with these carbon, silicon, tin, lead. So that means the properties of this germanium, they resemble with the elements which are present in this group 4A. So that is why this was the biggest achievement of Mendeleev's periodic table, that he could just not only predict these elements, but he could also tell the properties of these elements which were discovered later on. So can you tell me what was the next element which was predicted by the Mendeleev? That was Ica boron.
The Ikabur.
Aluminum.
Boron.
Ika boron is aluminum, right? Oh, it's
Exactly.
gallium,
No,
my
no.
bad.
It is not aluminum. It is not gallium. It is the scandium.
How?
Oh,
Okay, tell me first. It is your group 3A,
That's
right?
cam.
yes, E2O3, EH3.
Then it is your
It's third B.
E. Exactly,
Scandium is
third B.
third B.
Exactly. So now you can see here that first it was here boron, then it was your aluminum, and then it was here your Ica aluminum. That is actually now your
Gallium.
gallium. Exactly. And now what was here? Here was the scandium.
Scandium.
Yeah, but first it was not discovered, and so that is why he just placed the empty space here, and it is just after the boron directly in the group 3B. So that's why it was just told by the Mendeleev as Ica boron. So sometimes it is asked that which element is Ica boron according to Mendeleev. So it is the scandium. I hope you will remember the symbol of scandium is Sc. Scandium, atomic number 21.
So what is Ika aluminum?
Aluminum is gallium.
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 Okay, I will write it again. Eka aluminum is your
Fine, sir.
gallium.
Fine, sir.
Okay.
Eka
Similarly,
aluminum, gallium. Eka
a-
silicon, germanium. Eka boron,
exactly.
scandium.
Eka silicon is your germanium, and similarly, Eka boron is your scandium.
All
Exactly.
DMs.
So have you noted down? So these were the three very important achievements of Mendeleev's periodic table. So now let us see the various defects, or we can say the limitations or the drawbacks of Mendeleev's periodic table. So let me write here the limitations, or you can also call them as
Yes, sir.
limitations or drawbacks, or you can also call them as defects in the Mendeleev's periodic table.
How many names, sir?
Yeah,
They
we
all
can call it.
meaningful.
They all have the same meaning. So defects of Mendeleev's periodic table. So can you tell me the first limitation? First limitation is the position of hydrogen. So can you tell me in the Mendeleev's periodic table where was this hydrogen placed by the Mendeleev?
The one
It was like
group
above
1A
everything, sir.
above everything like me.
Yes,
Yeah,
sir.
it was
Above all.
actually in the first A, right? It was
One
in
A.
the first A, isn't it? Group first A.
Yes, the
Discrimination.
first A, first
It's
element.
above all.
Okay, group first A. So can you repeat the elements? First A, it was
Yeah,
hydrogen, then it was
hydrogen, and then
lithium,
hydrogen,
sodium,
helium, sodium,
potassium.
potassium,
Exactly.
rubidium, lithium.
Exactly. So now can you tell me that here, if you just if you have noted down lithium, sodium, potassium, rubidium, what are they? They are all metals, isn't it?
Yes, sir.
But what is hydrogen?
Non
Sir, it's a gas.
Hydrogen is a
non-metal.
Oh, sorry,
gas.
sorry. Wait.
Yeah, it's non-metal. It is also a gas. Gas, all gases are non-metals, right?
It's
You
an
have to remember.
imposter. Yes, sir.
Okay.
Dun, 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 dun.
Now see here that hydrogen, it exists as diatomic gas, isn't it? Hydrogen exists as diatomic gas. Can you tell me what is this diatomic gas?
That means
So it needs two atoms to form a molecule.
stable, it needs
But
that to
That
follow
is-
the
only
duplet
two
rule. That means
molecules.
it
It
needs
cannot
two
exist on its
hydrogen
own.
atoms. That
No,
It
that's
Yeah,
cannot
wrong.
exist on its
hydrogen
own.
that means it
Hydrogen
forms the
Oxygen.
molecule.
in which there are two hydrogen atoms combined together. So this is H2. H2 is diatomic. But if
Like
you just talk
oxygen,
of the if
fluorine,
you
and bromine.
exactly oxygen, nitrogen, fluorine, chlorine, they are also diatomic. Now,
Bromine.
lithium, sodium, potassium, rubidium, they are metals and they are not diatomic, isn't it?
Yes, sir.
So that means hydrogen doesn't resemble with other elements which are present in the same group. Correct?
They
Yes.
Are
form
you
the
getting?
same oxides
Yes,
and
sir.
hydride.
Sir, but
Yeah, hydride.
Yeah, they
Okay,
still form the same.
for example, if we just talk of hydrides of other elements, they are all ionic. But this, the hydride of H2, that is covalent. This H2 is what? It is a covalent molecule, isn't it? H2
Yes,
is
can
covalent.
hydrogen lose an electron, sir?
Yeah, hydrogen can lose electron.
Sir, I
Hydrogen
mean
can
hydrogen atom.
hydrogen can also gain electron. For example, I will tell it above. For example, if hydrogen loses an electron, it will become H positive. H positive is what? It is a proton. It's known as proton because there isn't now any electron inside it. There is one proton, so that is why you have to remember hydrogen can lose its electron. It can also gain electron. When it gains electron, it becomes H negative. H negative is known as hydride ion. This is very important.
So if it loses one electron, it's just
yeah.
a
Sir, but
proton. That's it. Nothing
It
else.
is
there
just
be an atom without any electrons, sir?
because that is now not the atom, that is now the proton only there because electron has already been removed. It
It's
is
no
now the
longer an
proton.
atom.
There's zero neutrons as well, so it's not even an atom now.
Yeah, that's right.
Exactly,
It's
it is
just a
not the
proton.
atom now. It is just the. That's why I call it as proton. H positive is it's known as proton. It is not the atom. It is just there the proton only. You have to remember.
Minus is just the electron.
Yeah, minus means it has gained one more electron. So this is your hydride ion. So this is the atom there. Okay, so have you noted down this?
Yes, sir.
Yes, sir.
Shall I move to the next page?
Yes, sir.
Yes, sir.
So now we have seen that this hydrogen, it doesn't resemble with the group first elements, first E, that is other elements of the same group, just like lithium, sodium, potassium. But now if we just talk of group 7E, can you tell me the elements of group 7E?
Yes, sir. It
Sir,
is some. It is some.
sir, it is
Fluorine.
fluorine,
Fluorine,
bromine,
bromine,
and
iodine,
stars, sir.
manganese, IC,
No,
PCA,
what do you?
and then V.
They are not
He
there.
asked
They are
7,
actually
8.
just-
Oh,
they are
7A. Sir.
7A. Okay.
Fluorine, bromine,
Fluorine,
iodine.
bromine, iodine, ester. Now
Yeah,
tell
see
me.
from Google and telling you know.
Now
No,
tell me.
Hey, we wrote it,
we
Rafi. What are
wrote
you
this.
talking about?
Yeah, we have already written this. Okay, now tell me, all these are what? They are all diatomic, right?
Also, there is one prediction below iodine, sir. There is no factor in the prediction. But still, sir.
Eka iodine.
Iodine.
Yeah, Ika, you can, but Mendeleev doesn't told at that time Ika iodine, so you have not to tell it.
Why,
Oh.
sir?
Because astatine, it is a radioactive element. Actually, you have to remember that after iodine, astatine is radioactive. For example, if you just talk of after
Sir, but
cesium,
how
what is
does
it?
that matter, sir? If Mendeleev does not know what how do we pronounce? Yeah,
Acetine is 57
Acetine.
atomic number.
I know.
This
If he like did not discover that element and does not know the properties of it, how can he say it's a radioactive element, sir?
he didn't say.
I didn't told that he told it is radioactive, but I am telling that astatine is actually radioactive. For that, this element he couldn't actually told it as Ika iodine. Only the three elements were
Prediction
there.
was wrong.
Yeah, only the three elements. That is why we are studying the limitation. There are limitations in the Mendeleev's periodic table. That is why we are studying this. Then we have the modern periodic table, in which we will all these limitations will get removed there. Now see here, these halogens, they exist as diatomic gases, right? Some are gases, some are liquids, but for example, fluorine, chlorine, they are your diatomic gases. They exist as F2, they exist as Cl2, right?
Yes, sir. BR.
Similarly, yeah, exactly. Br, it will exist as Br2. Now tell me here, if we just compare the hydrogen also exists as diatomic, that is H2. All these are non-metals, isn't it? Halogens are all non-metals. So can you tell me hydrogen? Hydrogen is also what? It is also non-metal. So that means hydrogen resembles with group 7A. So that means Mendeleev could also have placed this hydrogen along with this group, that is group 7A, but he didn't. So that is why it is the first limitation of Mendeleev's periodic table, that is the position of hydrogen. That means hydrogen, it resembles with the elements of group first A, but it also resembles with the elements of group 7E. So that means its position, it is not correctly defined in the Mendeleev's periodic table. Got
Sir,
it?
but in the modern periodic table, they placed hydrogen in group 17, but they blurred it. Sir.
Exactly.
Yeah, it's faded.
You mean fade?
Yeah, that's
We
what I
will see
said.
the modern periodic table we will see the modern periodic table in detail. Now let's see the second limitation of this Mendeleev's periodic table. That is the position of isotopes. So can you tell me what are isotopes?
Sir,
So they have the
isotopes are
same
of
atomic number but different mass
Different
number.
atomic mass.
Exactly. For example, if we just talk of isotopes of hydrogen,
and
that is
their
one.
properties will be
Protium,
same.
deuterium, and tritium.
Deuterium, no.
They'll have same
Deuterium,
properties.
I
Sir.
said it.
Protium, deuterium, tritium.
Hey, shut up there.
Yeah. Now, see, this is, yeah, exactly the protium, deuterium, and tritium. Now tell me that these isotopes, they have different atomic mass, isn't it? Is it correct? Exactly.
Yes,
But according to Mendeleev, what he did, he just placed all these elements in increasing order of atomic mass. So that means there should be different position for these isotopes. But when we see the Mendeleev's periodic table, there isn't any separate position for these isotopes. So you are
sir,
right
it
that
doesn't matter, sir, because isotopes have same properties as the original element, right, sir?
Are they having
No.
same physical properties?
No,
how
they do
how
not.
can you say
No,
they have
different
same physical
physical
Number of
properties?
properties,
protons,
same
same
chemical
properties, sir.
properties.
Same
Yeah,
chemical properties. I'm not talking
they
about
have
physical.
same chemical properties, but still their physical properties are different.
But it's
So that's
chemistry, right,
why,
sir?
Hey,
yeah.
verify that hydrogen up.
Now see here that there should be different position now, and there should be different place for these isotopes because they have different mass. Actually, the whole Mendeleev's periodic table, it is based on the atomic mass, increasing order of atomic mass. So that is why when he couldn't give any separate position for these, so this is also the limitation, and this limitation gets removed in the modern periodic table because the
But it's
modern
not there in the modern periodic table also.
Hey, the
No, modern periodic table is based on the atomic number. That is not based on the atomic mass.
Yeah,
When they have same
exactly.
atomic number, so
Stupid.
that's why they have the same position. They will have the
but
same
don't
position.
they assign atomic number with the mass numbers in increasing order of mass number?
Exactly. So I will write it here
But
that there is not separate position for isotopes. So there isn't separate position for isotopes. So this is also the limitation because isotopes, when they have different mass, Mendeleev should have given them the separate position in the periodic table. Similarly, let's see the next limitation. Next limitation is anomalous pair. For example, now, if he
Thomas,
just
what?
created anomalous pairs, I will write it. What are these? Tell me that in the Mendeleev's periodic table, elements are in increasing order of atomic mass, isn't it?
Uh,
But when you just see the argon and potassium, so can you tell me argon and potassium? What is the mass of argon? Can anybody tell me?
40,
yes,
40, sir.
argon. It is
40,
some.
40, 40,
It is
40.
I forgot.
39.9. Yeah, that is roundly, that is taken as rounding of 40. Okay.
Yes, sir.
But that of potassium, it is 39.1. That's taken as 39. So which
Yes.
should be first? Which should be first according to
Sir,
No,
Mendeleev?
Potassium.
Exactly.
according to Mendeleev, potassium should be first. But according to
Exactly,
modern,
because
argon is
Mendeleev
first.
has arranged all the elements in increasing order of atomic mass. So first it should be potassium. But when you just see the Mendeleev's periodic table, argon is first, then potassium is written. So that means
Stupid.
this is the anomalous pair. Anomalous
Higher.
means anomalous means that doesn't match. That doesn't
As
actually follow the increasing order of atomic mass here.
sir,
Got it?
it's because hydrogen is there in the first period, sir.
Yeah, hydrogen is there. That doesn't matter. If hydrogen wasn't there, still there will be this anomalous pair. It is not only okay. If you are just talking of this, then tell me the next one. That is the cobalt and nickel. Where is
No,
cobalt
sir,
and
I'm saying hydrogen is there in the first. That's why it pushes down potassium and it goes under
Pushes
argon.
down now. What?
bro,
What is
that's
this,
not
Noah?
how it works, da.
Is that
no,
not
no,
how
no.
it
That's
works?
not how it works.
See,
They
see,
get a
see. Now,
separate
in case
group
of,
of it.
can you just tell me cobalt and nickel? They are just in the group 8, right?
Yes, sir.
Okay. Can you tell me that which, according to Mendeleev, he has just placed cobalt first, then he has placed the nickel, isn't it?
Yes, sir. Iron,
But
cobalt, and nickel.
But when you just check their atomic mass, what is the atomic mass of cobalt? It is
So cobalt is
59.8.
59.9.
Yeah, 59.9 or 59.8. But when you just talk of nickel, it is 50.
So it's
Eight.
It's
59.1.
exactly 59.1. So that means this is also the anomalous pair. Got
But
it?
it was wrong in this also.
Exactly. This is also the anomalous pair. I told that there are some anomalous pairs in the Mendeleev's periodic table. That means which doesn't follow the increasing order of atomic mass.
What is this
Yes.
rounding off, sir? How did he round off cobalt to 859, sir?
Didn't.
It
We
is,
are not rounding off. He didn't round off at that time. Now see the next anomalous pair. What was the next anomalous pair? Can anybody tell me? It was the tellurium
maybe it is
and iodine. Tellurium and iodine.
what am I ordered? Oh, tellurium.
Tellurium and iodine. Can you tell me which group they are?
Sir,
So they are a group
beryllium is in
group 6.
group 6A.
Plus 2. Group 8.
Actually, it's in group 6A.
It's in
I was
group
wrong.
6A.
That's what I
That's
said. Yeah.
correct.
Can you tell me argon and potassium? They are in which group?
Ah,
The
sir,
argon
they're
and
in group
potassium
zero,
are
group zero, group zero.
group zero.
Exactly. Argon is in group 0 and potassium is in
Potassium
group
is in group 1A, sir.
exactly 1A. Okay, now tell me tellurium and
And
iodine.
whole
They are
thing is in group zero, sir. Neon, argon, krypton,
exactly.
xenon.
Noble gases are in the group 0. Noble gases are in
You
group
didn't know
0.
where to pick them.
Now tellurium it is in group 6 and iodine it is in group 7, right?
Yes, sir.
Okay, now tell me tellurium its atomic mass is
128.9.
128.9. Okay, let's say this one. But that of iodine it's 127 point something, right?
7.6.
Okay. So which should be first?
Sir,
Iodine.
Selenium.
Iodine should
Iodine
be
should be first.
According to
iodine should be
Mandela.
first, but when we just check the Mendeleev's periodic table, there it is tellurium first. So that's why these three pairs they are the anomalous pairs which do not follow the increasing order of atomic weight. So that's why this is also the limitation. Got it?
Sir, what about iron, sir? Iron also has 56, like cobalt and nickel. Oh, sorry. Cobalt and nickel are 59.
Okay. So shall I move to the next
Like
page?
56 is like 59.
Yes, sir.
There's 3 difference. Yes, sir.
One
You can go
second,
to
sir.
next.
1 second, sir. 1 second.
Okay, just note
Bro.
down.
Tomorrow you guys coming?
Where? Tomorrow school.
Oh, yeah.
Yeah, come.
I have to come.
There.
I
Sir,
have
they
to
gave
submit my
chemistry papers today.
Yes, sir.
Are you having chemistry paper?
Yes, sir. Done, sir.
When?
Sir, ma'am made 10 marks correction mistake in my paper, sir.
Then I
Why?
am the
I
rounded
don't
one.
know. I don't know, sir. Everything she didn't even put
So
marks.
I think ma'am hates Pongal, sir.
Sir. She itself told.
So every question she says, she's like, ma'am, you made a mistake.
10 marks, sir.
Oh, that's very huge. 10 marks means a lot.
Yes, sir.
He went from like 45
Yes,
to 55. 55 sir.
Now, see here the next limitation that is now when we just check that some elements they have different properties, but they are still kept in the same group, isn't it?
yes, sir. Like hydrogen.
Not only hydrogen, for example, if you just talk of group first, for example, tell me group first. If you just check the elements, there is first A and first B. Are they matching together? No.
Yes, sir. No, I mean, no.
You have it right here. First A and first B. When you just compare these elements, they should have same property. But when you just compare, for example, you are having here the lithium, then sodium, then potassium, then rubidium, isn't it? But
Yes,
when you just see the first B, that was what? That was the
calcium, silver,
copper,
gold.
silver, and gold, right?
Copper, sir. Calcium, sir.
No, in
Copper,
the first
silver, and
B,
Oh,
gold.
copper,
Calcium.
bro. My
Yeah,
copper.
what are you
my U
talking?
looks like a A, sir. Sorry, sir.
Okay. Now, can you tell me, are these metals matching together? If you just talk of lithium, sodium, potassium, rubidium, cesium, they are just soft metals, right?
Sir.
Sir.
They are soft metals. That means they are so much soft, they can be cut with the help of knife. They are very soft. But when you just talk of copper, silver, and gold, they are hard metals, isn't it?
Sir.
So
Yes, sir.
that means their property doesn't resemble with each other. Otherwise, they should have some property because they were kept in the same group. So that means I will write it here that properties of subgroups doesn't match with each other. Does not
Sir, is
match.
rubidium named after a person, sir?
No.
No, because rubid
Was
sounds like a
something
name.
named after a
Properties of.
person?
Rutherfordium is named after Rutherford.
Can you hear me?
Yes,
Sure.
sir.
But your voice is so slow coming.
Oh,
So can you hear me
Hello?
now?
Can you hear me now?
If
Yes,
yes,
speak,
sir. We can
yes,
always
sir,
hear you, sir. It's fine
yes.
only.
So if
But
I
from
speak
your
fast,
side,
you
audio
hear
is
me
very
in a normal voice. So
Maybe some technical issue.
if I speak fast, maybe you can hear
slow.
me in a normal voice.
Yes, sir. He means like the volume is so low.
If I so if I like
Not
someone
slow,
will
low.
understand me perfectly. What is your guys' favorite chemical element?
Copper nitrate.
Hey, I said element, ra.
Oh, element. Yeah, I don't have any favorite element.